Hi students, welcome back. So far we've learned how to find area of a triangle using the formula half times base times height. In this week's video, we're going to learn how to find area of any kind of triangles using a different methods. And the questions are from assignment 6.2. Right, let's look at the different types of triangles that we've come across. Let's start off with having the right angle triangle, the acute angle triangle. The acute angle triangle meaning that each angles in the triangle it's less than 90 degrees but more than 0 degrees. And of course, obtuse angle triangle. It's called obtuse angle triangle because one of the angle ACB it's more than 90 but less than 180. So for these three different types of triangle, because we're given the base and the perpendicular height, we can find the area of the triangle using the formula half times base times height. Right, let's look at what happened in a situation when the height of the triangle is not given. So let's look at activity 1. So in activity 1, you're given the triangle ABC, right? And you're given the angle ACB. We're going to call it phi. It's an acute angle. Right, so how do you find the area of a triangle ABC? Supposing if you're given the base to be B and the height to be H, then of course the formula will be half times base times height. Right, so we're going to use this formula, half times base times height, to derive another formula to find the area of this triangle ABC when you're not given the perpendicular height. Right, so how do we go about doing it? So let's look at triangle BCD. Let's focus on triangle BCD. Right, so triangle BCD, it's actually a right angle triangle as indicated here. And if triangle BDC is a right angle triangle, we can just use the concepts of Picasso to find the value, to find the ratio for sine phi. So the ratio to find the ratio for sine phi will be to take the length of the opposite side divided by the length of the hypo. So if you look at the triangle BCD, the side that is opposite the angle phi, it's H, and the hypo, it's the letter labeled by the letter A, which is opposite the 90 degrees. All right, and what we're going to do is we're going to multiply by both sides of this equation with the letter A, and we're going to make H the subject of the equation, and you will get H equals to A sine phi. So what we're going to do is we're going to substitute this value into equation 1. All right, so equation 1, what we have here is half times base times height. So I'm just going to replace this letter B. We're going to just replace this letter H because you're not given the height. We're going to replace this letter H with A sine phi. And this is what we get. Half times B times A sine phi gives you half AB sine phi. So what this means is that if you're not given the perpendicular height of a triangle, that means if you're just given two sides of the triangle, okay, side B and then side A, and then if you're given the included angle meaning the angle that is wedged in between the two sides, so this angle here, then the area of a triangle ABC can be found using this formula half AB sine phi. Right, so the next questions we should be asking ourselves is the formula that we have just derived, half AB sine phi, that formula, is it applicable to find the area of an obtuse angle triangle? So this is what we're going to do in activity 2. So here we're given a obtuse angle triangle where the angle ACB is an obtuse angle and it's given is labeled as phi again. All right, and we're going to let the base of this obtuse angle be B also. The perpendicular the perpendicular height to be h. So of course, the formula to find this triangle will be half times base times height. So similarly, we're going to use this formula half times base times height to derive another formula, all right, to find the area of this obtuse angle triangle. So how are we going to do it? So if you look at the dotted lines here, CX, and the dotted lines BX, you see that we are able to form a right angle triangle here, right? And in this right angle triangle, I have acute angle BCX, and I call it theta. So I'm going to use this right angle triangle because I could only use Tricasso on the right angle triangle, not on the obtuse triangle. Okay, so in this right angle triangle BCX, I'm going to find the ratio for sine theta. Okay, right, so sine theta will be equals to h over a, opposite over the hypo, right? And again, I'm going to, what's the next step? Yes, multiply by a on both sides, like what we have done earlier on for the acute angle triangle, and make h the subject. So I would get h equals to a sine theta. Okay, here we need to apply some concepts that we've learned earlier on in my earlier video, assignment 6.1. You can refer to it. We can actually apply this concept here, that sine theta it's equals to sine bracket 180 degrees minus theta. So if you look at how this phi and theta is connected to each other, you see that phi plus theta is equals to 180, right? So therefore, theta, therefore phi, it's 180 minus theta. Right, so if you're going to replace your 180 degrees minus theta with your phi, right, you'll see that sine theta it's actually equals to sine phi. Okay, this is one way of explaining it. Okay. Right, so what we're going to do is, since sine theta is equal to sine phi, I'm just going to replace the sine theta with sine phi. So therefore, h is equals to a sine theta is also equals to a sine phi. All right, so what are we going to do? We're going to substitute this letter h with a sine theta, and let's see what we substitute the letter h with a sine phi, and let's see what we get. Yes, we also get the same formula that we have got earlier on, half AB sine phi. So in other words, this formula half AB sine phi, this formula can be used for an acute angle triangle, can also be used for an obtuse angle triangle. How about a right angle triangle? Do you think we can also use that for a right angle triangle? Yes, you can also use that. So how can we use it? If you're going to use it for a right angle triangle, then that will become half AB sine 90 degrees. Your angle phi will be 90 degrees. And if you use a calculator to evaluate sine 90, that gives you 1. If you use a calculator to evaluate sine 90, that gives you 1. So you end up getting half AB, which is the formula that we have learned earlier on, which is half times base times height. Right. So therefore, half AB sine phi, it's rather useful formula. It can be used to find area of a acute angle triangle, obtuse angle triangle, also a right angle triangle. Right. So in summary, if we are given a triangle and if we're given two sides, of a triangle and the included angle, right, then we can use the formula that we've learned earlier on. So if you look at the triangles on the screen, okay, I have a triangle that is given all the three angles. The angles are the one that is in uppercase. Okay, if you see that the angles are labeled using uppercase, and then the sides that is opposite your angle is labeled lowercase, right? So you see that if you like, some people like to draw arrow like that, you know, a arrow to the sides, which is lowercase. Okay, right. So supposing if you're given side B and C, all right, and the angle, included angle meaning the angle that is in between the two sides. Okay, it's you can do it like, you know, your one finger on the left hand and another finger on the right hand pointing to each other to form a this symbol, and then the angle that it's in between the two sides, that is called the included angle. This is called the included angle. This is what I mean. Okay, right. So if you're given that, then we can just use take half multiply by the length given for side B and the length given for side A times sine. The sine must be there, and then the angle given. All right. Supposing if you're not given side B and C, supposing if you're given side A and B instead, side A and B, then the included angle will be your angle C. Okay, the angle that is between your side B and A will be angle C. So in this case here, the formula that you should be using will be half AB sine C. Okay, and supposing if you're given side A and side C instead, then the included angle will be B. So the formula will be half times A times C times sine B. So this is how you use the formula to find area of any types of triangle. So the important concept here is you must ensure that the angle that you use has to be the angle that is in between the two sides given. Okay. Right. So in this slide here, I'm going to address some misconceptions. That means not applying the formula correctly. So supposing I'm given the triangle, okay, with two sides given, AC to be 5 centimeter, BC to be 7 centimeter, angle BAC to be 62, and angle ABC to be 55. All right, we're going to look at two student solutions, John's solutions. So John's applied using this method. You take half times 7 times 5 and then times sine 62. And it worked out to be 15.5 cm squared. Let's look at another student solution. Let's call this person Mary. And Mary used half times 7 times 5, but in this case here, she used 55 degrees instead of 762. And the answer worked out to be 14.3 cm squared. Right. But the sad thing is, the both solutions are not correct. So why is it not correct? Why is John's solutions and Mary's solutions, both of them, the solutions are not correct? Right. The both solutions are not correct because they did not apply the formula correctly. The formula says that to find the area of this triangle ABC, you have to use half times AB times sine C. What does this angle C mean? The angle C must be in between sides A and B. And if you're using half times AC sine B, it means the angle B must be in between the sides A and C. Or if you use half times BC sine A, then the angle must be in between B and C. Right, so since we're given these two sides, 5 and 7, then the angle that I must use will have to be this angle here, ACB. It must be this angle. This is the angle that is in between your sides, 7 cm and 5 cm. Right, so what John and Mary have not done correctly is they have not used the correct angle. They just simply choose any of this angle given in triangle, and that's it. Okay, right, so therefore the correct solution should be, you need to find the angle ACB first. Okay, using 180 minus 62 minus 55 to get 63, and then use the formula half times 7 times 5 times sine 63 to get 15.6 centimeters squared. So when you apply this formula, you have to remember that the angle that you use have to be the angle that's in between the two sides given, or called the included angle. Alright, let's look at another two more student solution. So what happened now is that the two students managed to find the angle ACB. Right, the two students understand that we have to use the included angle, that it's the angle that's between the two sides, 7 cm and 5 cm. Right, so let's look at Peter's solution. Alright, so what's wrong with Peter's solution? Yes, he forgot to include times sine 63. Right, he just used half times 5 times 7. He forgot that this is not a right angle triangle. Okay, so this is what is missing here, so therefore his answer is incorrect. And then how about Jane's solution? Yes, what's wrong with Jane's solution? Correct. Jane's used cosine instead of sine. Right, so it has to be half times 7 times 5 times sine 63. So therefore, you have to remember the formula correctly and apply it correctly. Right, after learning the new formulas to find the area of a triangle, let's put our knowledge into practice. Let's look at this question here. You're given a triangle with two sides and two angles given. Right, so if we're going to use the two sides given, then what is needed? Yes, what is needed is the angle that is between the two sides given, or the included angle. So therefore, we have to find angle GHI, which is 180 minus 62 minus 57. That gives you 61 degrees. Right, so with this included angle and with the two sides given, now we can apply the formula that we've learned earlier on. That will be half times 9.5 times 10 times sine 61. And you express the answer to three significant figures, that will give you 41.5 meters squared. So this question is a direct, not exactly direct, because you still have to find the included angle, but it's also quite straightforward. Let's look at the next question. Right, so in this question here, you're given a rhombus with all the four sides equal. Oh, we don't know whether it's a rhombus or not, because it may not cut, the diagonals may not intersect at 90 degrees. All right, so this is just a quadrilateral with four sides equal. But the formula that we've learned earlier are meant to find area of a triangle. So what we need to do is we have to do some dissections. Right, that means we need to dissect this quadrilateral into two triangles. So I'm going to show you two different methods of doing it. Some students may dissect it this way. Right. So we're given the two sides here. So what is needed is to find this included angle. But to find the included angle, I would have to find angle SQR first. Right, which is 78 degrees divided by 2, gives you 39. And then what we have ended up here is an isosceles triangle. So the isosceles triangle, why is it an isosceles triangle? Because you're given the four sides to be of the same length. So this is also 8.5 meter. Right, so therefore it's an isosceles triangle. And then we can go ahead to find the angle QRS. Right, which is 180 minus 180 minus 39 times 2, because there are two angles each 39. They give you 102. And then we can go ahead and apply the formula we've learned earlier on. Right, why is it that we need to times 2 here? Because the equilateral comprises of two triangles. This formula that we have here, half times 8.5 times 8.5 times sine 102, is to find the area of one triangle. But we are having two triangles here. 1, 2. Therefore, we need to times 2. So this is method 1. Right, so what is method 2? Method 2, it's a shorter method. Alright, it's the preferred method. Okay, if you were to dissect it this way, right, then you find that there's actually lesser work need to be done. Okay, right, so we're given we just concentrate on this triangle TQR. You're given the two sides 8.5, 8.5, and the included angle to be 78. So we can just find the area of this triangle TQR and then times 2. Right, so you end up getting the same answer, but method 2, it's the preferred method. Alright, let's look at another question. In this question here, part I, just to find the area of triangle ABC. Right, so this part I, we can just use the formula directly because you're given the two sides and you're also given the included angle. Right, so that it's relatively alright for part I. Okay, but for part 2, alright, we will have to make use of what we have found in part I to find the perpendicular distance from A to BC. From A, so you need to draw a perpendicular line from A to BC and find the perpendicular distance. Alright, so let's do part I first. Right, so as mentioned earlier, we're given the two sides and the included angle, so we can just apply the formula directly, which is half times 32 times 43 times sine 67. So with that will give you 633.31. We will need an intermediate answer which is more than 3 significant figure, right? Because we need that answer to solve part 2. Right, so if you express it to 3 significant figure is 633 cm squared. Okay, now let's look at part 2. So for part 2, right, I would advise you to draw a diagram because usually a picture tells 1,000 words. So if you were to draw a diagram, alright, so what is needed is to draw a perpendicular line from A to BC. And we're going to let this perpendicular distance be the letter X. Right. Right, so if you were to draw a diagram like that with a perpendicular line and then with the base BC, right. Right, can you see that we can actually go back and use, well, go back. We can actually use the earliest formula that we have learned, which is half times base times height. So to find the area of triangle ABC, I can just use half times X times 43. And of course, this area would be the same area that we have found in part 1 because we're talking about the same triangle, right? Right, so we can just take half times 43. Use a calculator, half times 43 will gives you 21.5. Then you divide both sides with 21.5. That will give you X to be 29.5 centimeter expressed to 3 significant figure. Alright, so we have done questions on how to find area of a triangle. right? Not given the included angle, so you need to find the included angle. We have also done questions on how to find area of a triangle, and using the area of a triangle to find perpendicular distance. So in question 9, what we're going to do here is you're given the area. Okay, so it's the other way around, it's the reverse. So given the area of this triangle PQR, and you're asked to find the sides of the triangle, and the sides of the triangles are given in the ratio. This is the ratio given to you. 3QR equals to 4PR. And you're asked to find the length of QR. So usually, whatever you ask to find, right, find the length of QR, this is what you need to find, right? So what you need to find, you just let it be a letter A or B or C or whatever. Okay? So we're going to let QR be the letter A. Don't let it be the letter X, because it is very confusing, because your formula is half times A times B times sine C, right? If you're going to let it be X, can you see how confusing it could be? And some other X and then sine C, right? So it's rather confusing because there's so many X here. So it's better to let the length of QR be the letter A or B or C or whatever, but not X. Okay, so I'm going to let it be the letter A. All right, so let's use this ratio. So 4PR is equals to 3QR. And if you replace your QR with letter A, then 4PR is equals to 3A. So PR is equals to 3/4 A. So with this information, we're going to plug into, yes, put it into our triangle. So PR is 3/4 A, QR is A. All right, so we can actually use the formula now, which is half times A times 3/4 A times sine 55. Remember the sine must be there. Will gives you the area, which is 158. Okay, and that's rearrange it. When I say rearrange, it means things like half and 3/4, you can put it together and sine 55. Because all this thing you can just use a calculator to evaluate. And A times A gives you A squared. So this one you can't use calculator to evaluate. Alright, so you just leave it at one side. So this, if you use a calculator to evaluate, you will get 0.3072 A squared equals to 158, and then you divide by 0.3072 on both sides, you get A squared equals to 513.323, and then you need to square root it. So there will be two answers, because this is an even number. But of course, A represents the length, so the length cannot be a negative number, so we reject the negative one. So therefore, the length of QR will be 22.7. 22.7, yes, because we let it to be A centimeter, so there's no need to put cm there, so it's just 22.7. Okay, right, let's look at the second last question. And if you look at the questions carefully, you will see that there's no diagram given. That the diagram is not given is because we are asked to find the two possible values of the angle xyz. Right, so actually the hint is already given here for us, that the angle xyz, which is the angle between the two sides given, these are the two sides given, so the angle that is between these two sides can be acute, can also be obtuse. What do I mean by saying that? So let's draw the acute triangle first, the acute angle triangle. So this is how it looks like, where your angle xyz is an acute angle. Okay, so if it's an obtuse angle, then how would it look like? Yes, you will look at this way. Okay, right, so there are two possible types of triangle here, x to yz, which is the acute angle triangle, where we're going to let the angle be theta, and of course the x1 yz, which is the obtuse angle triangle. Okay, so let's find theta first. Yes, so that will be half times 13 times 16.2 times sine theta. That gives you the area to be 59.5. And then you can basically just use your calculator to work this whole chunk of thing out. Right, which is 105.3 times sine theta gives you 59.5, and you divide by 105.3 on both sides, you get sine theta. To get theta, you just sine inverse the value, and that works out to be 34.41 degrees. To express it to one decimal place, that will be 34.04. Okay, right? Right, so that will be the acute angle. Then how about the obtuse angle? How do you get the obtuse angle? So the obtuse angle will be how do we get 180? Why is the obtuse angle 180 minus 34.41? How do you justify this part here? Yes, because if you were to recall what we have learned earlier on, that sine acute angle, sine over theta, if theta is at acute angle, the answer will be equals to sine of 180 minus theta. So if your theta is an acute angle, then 180 minus theta will give you an obtuse angle, right? So in other words, sine 34.41, okay, if you were to work out this answer, that would be put it to three significant figure is 0.565. And if you're going to work out sine 180 minus 34.41, which gives you 145.59, and that also give you 0.565. Okay, so we're actually using this concepts that we have learned earlier on to find the obtuse angle. Okay, so this is how you go about solving these questions. All right, let's look at the last question. So the last question is the most challenging questions because first of all, the diagram is not given to you. And secondly, you're given the quadrilateral and it's not a triangle. And not only that, I think it's a bit challenging to draw the quadrilateral. Okay, but not to worry. Right, let's look at what are the informations given to you. So you're given the sides AB to be 3.2, BC 5.1, angle CB 34.4, and you're also given the diagonals BD. Okay, so some of you may have forgotten what are diagonals. So I'm going to show it to you. So supposing if you have a quad that is drawn in this way, then the diagonals will refer to the one that I've drawn for you in red. That will be the first diagonal, and the one in blue will be a second diagonal. So basically, this is how the diagonals look like. Okay, so we draw the smallest side first, which is AB 3.2. So let's make that to be our base. Okay, so the order, it's important, A, B, C, D. So after you have drawn your A, B, of course, the next point will be C. So supposing we don't know where point C is, right? We just put point C here. And then we join it up. So if your C, the point C is there, then point D definitely have to be somewhere here, right? Because like what I've mentioned again, the order is important. So A, B, C, and D. So you join all this up to form a quad, right? And then we can find our diagonal BD here. So that will be our diagonal. Okay, we use a different color to indicate the diagonal. Let's use red color. So that is your diagonal. And you're told that the angle ABD is obtuse, ABD. So that means this angle must be more than 90. But looking at the diagram we have just drawn, your angle ABD does not look obtuse. It's an acute angle. So therefore, that gives you an idea that, I think my point D is not correct, right? Point D should not be there, right? Point D should be more like in the positions of point C to make ABD obtuse. So therefore, you will see that this diagram is not accurate. Okay, so this point here should be more like my point D rather than point C. All right, so if that is the case, then yeah, so this angle would look more like 90 degrees, which is what is required in the questions. It has to be obtuse angle. So if your point D is there, then of course your point C has to be somewhere here, right? It cannot be the other side. If it's the other side, then if we join them up, then the order is not correct anymore. The order will become A, B, D, C. It's not correct. right? The order is not correct. So therefore, your point C cannot be there. Okay, so your point C will have to be somewhere there. All right, so now we can join all the lines, and we can put in the information given. So you're given AB is 3.2 cm, BC is 5.1. Angled ABD is obtuse, yes. And angle CBD is 34.4 CBD. So this angle here, which I think our diagram makes sense because CBD it's 34.4, which is the cube angle, and our diagram shows that CBD is in the cube angle. All right, so first part is to find the area of triangle BCD. Oh, you're also given BD to be 7.5. Okay, we can fill that in also. Right, so in these questions is challenging in the sense that you just need to draw the diagram correctly, draw accurate representations of the diagram asked in the questions, and then you should be able to solve the questions. Right, so area of triangle BCD, so you're given the two sides already, 5.1, 7.5. You're also given the included angle to be 34.4. So we can just usually use half times 7.5 times 5.1 times sine 34.4. That gives you 10.8 centimeters squared. So that's part 1. Then part 2 is to find the angle ABD. Alright, so we're going to let the angle ABD be theta. We don't know what the angle is, so we're just going to let it be called theta. Right, so half times 3.2 times 7.5, the two sides given, and then your theta, which is the included angle, times sine theta gives you the area. The area given here to be 11.62. So this whole chunk of thing, you can just use your calculator to work this out. Right, and you get theta to be 75.54 degrees. Right, so therefore your angle ABD, it's because your angle ABD has to be obtuse angle, right? So we will have to apply the concepts, these concepts again, that we have learned much earlier. Okay, the sine ratio of an acute angle is equals to sine ratio of an obtuse angle, right? So therefore I will have to take 180 minus 75.54 to get my obtuse angle for ABD, right? Because in the questions you're told clearly that ABD must be obtuse. Right. Okay, so this is the last questions, and this complete the whole video for finding area of a triangle using half absinC.